In this lecture, we are going to discuss about fundamental theorem of algebra. First is a statement. Every polynomial of degree n greater than equal to 1 has a 0. That means 0 means a point z1 is said to be 0 of fz if f of z1 is equal to 0. That means if I put z1 here, then f of z1 is equal to 0, then this is known as 0 of the function fz. That is, this z1 act as the root of this fz. Now proof. Let pz equal to this be a nth degree polynomial. Okay, nth degree polynomial where n is greater than equal to 1, and this will be nth degree only when the coefficient is not equal to 0. We assume that pz has no 0. To prove this theorem, that every polynomial has at least one 0, that is at least one root, we have assumed that pz has no 0. Then we will show that, we shall show that pz, not fz, pz is constant. If pz has no 0, then pz is constant. We assume pz has no 0, then we are going to show that pz is constant. Next, we define a function, let fz be defined by pz, fz equal to 1 by pz. Now, then since pz is differentiable polynomial function and polynomial function is differentiable, so fz is analytic. Okay, then fz is analytic of C. Now, and pz is our never 0. Since pz never 0, so rewriting pz can be written as in this form. Here from pz we can take, in the right hand side of pz we take zn common, then this can be rewritten as zn equal to a naught by zn z to the power n plus a1 z to the power n minus 1 plus dot dot dot. The last term is now a to the power a suffix n. Next, take the modulus, that is modulus of pz will be modulus of right hand side. So modulus of right hand side, then this become pz modulus is equal to zn. Since by using property of modulus, if z1 z2 product of z1 z2 is equal to z1 plus z2, so generalizing this to n number of complex number, we will get this one. multiplied with a naught by Zn plus a1 by Zn minus 1 goes up to an. Okay, modulus close. Here all the term where as z tends to infinity, all this term becomes 0 except we will left with an. So as z tends to infinity, this pz tends to infinity. This implies modulus pz tends to infinity as mod z tends to infinity, so that fz tends to 0 as z tends to infinity. Okay, that means fz is bounded. Fz is bounded. Okay, when fz converges to 0, fz is bounded. Fz is bounded and fz is analytic. So by Liouville's theorem, by Liouville's theorem, Liouville's theorem, Liouville's theorem, Liouville's theorem, Liouville's theorem, fz is constant. Fz is constant, and fz is defined as 1 by pz. When fz is constant, our pz is also constant. Okay, that means we get our result. Yeah, first write this one. Pz is constant. We have assumed that pz has no 0, then we have get that pz is constant. Hence the theorem is proved. That is, every polynomial of degree n greater than equal to 1, where n greater than equal to 1 has a root. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.